Washington State University. Go Cougs!
Welcome back to the course on collecting smartphone sensor data using iOS. In this third part of Module 1, we'll be looking at the Swift programming language. As we mentioned earlier, the Swift language is the main programming language for developing iOS apps. Now, this course assumes that you have some experience programming, and it does not give a complete overview of the Swift language. For that, I would recommend that you go to swift.org and take the Swift tour that's provided there. One nice aspect of Xcode is that it allows you to create what's called a Swift playground. And here's a screenshot of a Swift playground. It's basically a window that allows you to try out various simple Swift constructs, but doing so in the context of iOS. So it actually imports parts of iOS so that you can try them out and try out various aspects of the Swift language as you're developing your app. So before we get started with Swift, let me go over to Xcode and start up one of these playgrounds. So I'll start up Xcode. And to create a playground, it's much like a project. We do File, New, but in this case, we select the Playground option. There are various different playgrounds we could choose from, but we'll focus on iOS, and we'll use the default name. We'll create the playground on our desktop, and so you see that a link is created here for the playground, which we can double-click on at any time to bring up the playground. So looking at the playground, I'll make it a little bit bigger. We see that we start off with a few simple commands, and in the right panel over here, what's returned by each of those commands is output on the right. Now, in addition, if these commands actually print some output, then that will show up in this console, which we can bring up using this little arrow. So, for example, if I were to do a print of the string, we see that it actually outputs down here in the console. And in this case, the string that's returned has the extra new line character in there. Okay, so let's go back to the notes and learn a little bit more about Swift, and then we'll kind of be jumping back and forth between the notes and this playground to try things out. So like most programming languages, Swift has constants, variables, and types built in. A constant is essentially a variable that never changes. And so the keyword we use is let. And so here we're using let to define a constant numCandy, whose value is 4. Now once we assign numCandy to 4, we can't reassign it. Also note that we don't provide a type for the variable numCandy, or the constant numCandy. And in this case, Swift will infer the type based on the value we're assigning it. So since the value we're assigning it is an integer, it will infer that the type is integer. However, if we want to explicitly specify the type that the constant or variable should take on, we can add a colon after the name and then the explicit type that we want. So to create a variable, something that we can change, we use the var keyword. And so here we're creating a variable called shopping list. Now, Swift has several types built in, Boolean, which is true or false, integer, float, double precision float, and string. Swift also has several collection types. An array is an ordered collection of objects. A set is an unordered collection of objects. And a dictionary is an unordered collection of key value pairs. So we see here that our shopping list variable is being set to a dictionary. The keys are coffee and candy, the strings, and the values are 3 for coffee and what will wind up being 4 for candy. To iterate over a collection, we use the for loop, and since we are here iterating over a dictionary, we have 2 variables here to take on the key and the value for each pair in the dictionary. And here we're just printing them out. So I'm going to copy this code snippet and copy it into the playground. Now you should have access to the notes and can also follow along and copy the code into a playground yourself. So we see that the playground evaluates this code that I just copied in, and we see the output down here. It prints out the key value pairs from our dictionary, as we would expect. Note that it prints them out in the opposite order that they appear in this dictionary. And again, this is an unordered collection, so the actual order that we iterate over is undefined. If we did care about the order, then we would want to make this an array instead of a dictionary. Okay, let's go back to the notes and learn a little bit more about Swift. So one of the unique properties of Swift is what's called an optional type. Now, an optional type is designated by a question mark. So when you see this question mark, you should think, this is an optional type. And the way to think about an optional type is that it's completely different than the type that it modifies. So if we just had string here, then this constant would be of type string. Since we have string question mark here, we should think of it as a completely different type. It's not just a small modification to the string type, but it's a completely different type. And in this case, a variable of this type can take on one of 2 values, either nil, meaning it hasn't been set to anything, or a string. So an optional type is nice because it allows us to continue processing in the code whether a variable has been set or not, and allow us to explicitly look at those 2 possible conditions. Now, if we have an optional variable who we're sure that has been set, so we have an optional variable that has been set to something, then we can unwrap it using the exclamation mark. So in this case, we create a constant possible string, which is of type optional string, but it actually has been set to a value. So here we can unwrap it, and so now it's no longer an optional, it's actually just the string, hello. And so this unwrapped string constant is actually of type string, not optional. Okay, so let's see how this comes out in the playground. I'm going to copy it in. Okay, so you can see that the first line here, we're setting possible string to the string hello, so that's what's returned. But when we print it out, we see that it recognizes the fact that this is an optional variable, and so it will print out explicitly that it is optional. Whereas down here, after we unwrap that variable, we see that it is set to just the string hello, and it outputs as we would expect, hello, with the new line, and that's what comes out down here. Notice that we have this little warning here. If we click on that, you'll see that it gives us several different options here, mainly because it's saying, this is an optional type, are you sure you want to print it out like that? Usually we don't. usually we want to print it out either as, say, unwrapping it, so we can put the exclamation mark in there, and then it's just a hello, or we can put the question mark in there, and sorry, we can put the double question mark, I believe it was. Let's see. Yeah, so this first option here, we can give it a default value if we want. And print it out that way. So this way, if we actually set it to nil, then this is happy with that. It would print out the empty in this case. But now we see that our unwrapping is not happy, because this is in fact a optional that is set to nil, and so unwrapping it gives us the error. So that gives you a little bit of an overview of the optional variable type. So let's go back to the notes and we'll see one of the novel ways you can use this. So given that we have this optional type of variable, we can do something called optional chaining. And what this does is it basically allows us to evaluate the various subproperties of a variable if it's set to something. But if it's set to nil, normally that would generate an error if we try to access a subproperty of it. But by using optional chaining, it will, which is essentially putting in this question mark as we try to access the various subproperties, then it will stop. So if my string is set to nil, when it hits this question mark, it'll say, I can't go on anymore, I'm just going to return nil. But if my string is actually set to a string, then it will continue on, access the characters of that string, and then, which is an array, and then it will count the number of objects in that array. So down here in our code, we see we're creating a variable called myString, which is an optional type. We start out by setting it to nil. So if we try to access the characters and then the count of those characters on myString, we're going to get an error because these don't exist. But if we throw in the question mark, meaning that we're doing optional chaining, then if myString is nil, it won't go past it, and it'll just return a nil. But if we actually set myString to a string, then it will go past the question mark and correctly find the characters and the count of this string. Another nice way of using this optional chaining is in a if-then-else construct. So in this case, we are setting x to be the length of the string, or the count of the characters in the string, but we only want to do it if the string in fact exists. So in this case, if the string is nil, x will be set to nil, and this conditional will evaluate to false, and we'll do the else part. But if the myString actually holds a string, then we will access its characters and compute the count, and that will be set into x, and this expression will evaluate to true, and then we'll do the then part, which will print out the actual length. So this is a nice way to handle variables, whether they're nil or they're not, without having to put in a lot of extra code to check for the two different conditions. So this is called optional chaining. And again, let me copy this code into our playground, and we'll see how it works. So first off, again, we encounter an error because we are not putting in the optional chaining here. We're explicitly trying to access the properties of this variable, but the variable is set to nil, so those properties don't exist. Now if I comment that out, just to get rid of our error, now this next line, it in fact returns nil because it realizes that my string is nil. It doesn't go past the question mark. Next, we assign my string to the string, go Cougs, and now when we do this optional chaining, it realizes that the string is set, and it does in fact find the characters and the count. And in this case, this little code snippet here will also set x to that value and print out that the length is equal to 8. Now if we were to set the string here to nil, then the same code snippet will still operate without an error, but in this case it will print out the else bar because my string is nil, x will not be set to a count, but it'll be set to nil, and the condition will return false, and so we'll do the else part. So that's how optional chaining works, and again, it's useful for dealing with variables of the optional type, whether they're nil or whether they're actually set to something. As a side note, I should point out that one of the nice features of the playground is the ability to get at documentation. So on the Mac, there's an Option key in the lower left of the keyboard. If you hold down the Option key, you'll see that the mouse cursor turns into a question mark. And if you hover over, say, a type like string and click on it, then it brings up some information about that type, various ways of using it. And then you can click on the structure reference, and that will actually bring up some documentation. And so that's where we can find, for example, how we access the length of the string by getting the characters of the string and then the count. So that's a nice feature that allows us to get at the documentation of the various constructs in the Swift language directly from the playground. And this also works in Xcode as well. All right, let me go back to the notes and we'll press on with a few other aspects of Swift. So again, like most programming languages, Swift has functions, and functions are defined using the funct keyword. And functions, of course, can have arguments, and those arguments are separated by commas. Each argument has a name for the variable that will take on the value of that argument and the type of that argument. If the function returns a value, then we put the little dash question or greater than or arrow, and then the type of the value being returned. So in this case, this function just adds its two arguments and returns their sum. Now, if we want to execute this function, we will have to provide the names of these variables in the call to that function. So we have to say, since this is first, the argument is called first, and we have to actually provide that here, and then the value that that argument has, and same for the second argument. Now, if we don't want to do that, sometimes it's useful to remind you what that argument stands for. But if you don't really need to be reminded of that, then you can use this special underscore keyword before the argument names. And in this case, you do not have to specify the argument name. You can just pass in the argument directly. So now we can pass in the values 3 and 4 directly without having to specify their names. Okay, so let's copy this into our playground. So here you see we've defined the two functions, and their value, of course, is 7 in this case. Now if I try to use this first function, see that it's suggesting various options for me. So I'll call that first function again. You see that it goes ahead and fills in these argument names, which again is useful for reminding us what they are. So I can go ahead and type in a value, hit tab to get to the next value. Two, say, and then I actually get the output there. So depending on how complicated or how unusual the types are for the arguments, you may want to give the user some help as to what they are, or if they're simple, you can just pass them in directly and use this underscore approach. So that's basically how functions are defined in Swift. Lastly, we'll talk about classes. So Swift is an object-oriented language, and so it has classes. And the one nice thing about classes is that they encapsulate both the data, or the variables in that class, and the code that's used to manipulate those variables. So here we're defining a class called location, and this is kind of similar to what we would do in our sensor app if we wanted to store location information. We would store a latitude, a longitude, and an altitude, and optionally a heading. So a location is always going to have a latitude and longitude. Sometimes we may not care about altitude, and so this basically sets a default value of altitude to 0. And sometimes we'll have a heading and sometimes we won't. And so in this case, we're making it optional, saying that we may have a heading and it'll have a floating point value, or it may be nil, meaning we don't have a heading. And so we need to handle those appropriately. Now this heading and altitude, since heading's optional and altitude has a default value, we don't have to set those when an actual instance of this class is created. But latitude and longitude do need to be set. So to do that, we create a special function inside the class called init. Notice it doesn't have the funct out front. It's just called init. And init's job is to set the variables that haven't been initialized yet. So when we create one of these location class objects, we're going to pass in a latitude and a longitude, and then those will be set to the internal variables of the class. Now note we're doing a few unusual things here. One is we're not using the underscore here, but we're using a second argument. So what this does is the first argument is what the user is going to need to use to create or to pass in that argument. So you see down here where we're creating this location, this instance of the location class, we provide the argument name latitude and longitude and then give them their appropriate value. But inside this function, instead of using the long names latitude and longitude, we just want to use the shorter ones, lat and long. Now, we can do this in any function, whether it's the init function or it's a function we use outside of a class. But that's just another way that we can build the arguments to a function. Also note that we're using the self keyword here. Self is always, in a sense, a pointer to the specific object that we just created of this class. So as the class is created, the specific instance of this class is called self, and so this is just making sure that we set this latitude variable as opposed to maybe a local one. So this is the class variable latitude is being set to whatever the first argument is, referenced by lat, and then this is the internal class longitude variable set to long. So in addition to this initializer, and we can have several initializers for different types of things we pass in, we can also set the methods to for this class. In this case, we're creating a method called jump, and what jump does is it increases the altitude by 2. Now notice we don't put the self keyword in here. We could, and it's probably a good idea to make it obvious that this is the class variable altitude. But since there's no other local variables in this function that could be misconstrued, we just use altitude, and we know that it's going to refer to the class variable altitude. In this case, this plus equal is essentially an increment operator. We're incrementing the value by 2. Okay, so to actually create an instance of this class, here we create a variable called location1 and set it to an instance of the class, and then we call the jump method of that class instance. So again, let's copy this code into our playground. So as it's evaluated, we see that in both of these cases, these lines are returning essentially an internal pointer to the class instance. But I can, if I want, actually access this altitude variable, and we'll see that it has the value 2 over here. I can access the heading variable, and in this case it says nil because it is an optional and is currently set to nil. But of course I can set it to something and then I can access that value, and it of course comes out as a 0 now. So that's how we create classes, which are essentially complicated types that encapsulate the data and the methods that operate on that data. And we'll be using those quite a bit in apps. Okay, well that is all that we really need to start working on our app. And again, that's a very brief overview of Swift, and there's a lot more to the language. And again, I would recommend you take that tour if you want to learn more. But like I said, that's enough for us to make progress on our app. So in the last part of the module, we will finish off the interface to our sensor app.